So today's topic is frequency modulation using Hartley or Colpitt's oscillator. We will see how to get the frequency modulated waveforms. Okay. Now we have a common emitter amplifier. This is a bypass capacitor. So here I am employing voltage divider biasing. So this is R1, R2. This is radio frequency choke. That means for DC it's a short circuit and AC it's a open circuit. So here we have a coupling capacitor and this is grounded. This is 0 volts. Okay, this is RE for emitter stabilization. This is bypass capacitor. Okay. Now suppose if it is going to be Hartley oscillator, so you will be having a coil, this end is grounded. Now here you have a capacitor and this is the feedback path. This is coupling capacitor and then it goes here. Okay, and here we connect DC power supply plus VCC. Now this is L1, L2 and C. So now I want a frequency modulated. Here you will get the output, that is a sinusoidal wave. If you don't alter the component values, if everything is going to be fixed, then you will getting a sinusoidal waveform with fixed frequency. But what is the definition for a frequency modulated waveform? If the intensity of the signal, if the frequency of the carrier wave changes in accordance with the intensity of the signal, signal means the baseband signal, then we call it as frequency modulation. So we all know the resonant frequency for this circuit, which is given by FR. Resonant frequency is equal to 1 by 2 pi root LC, where L is equal to L1 plus L2. Okay. That means if these values are fixed, then we are going to get a fixed frequency output waveform. Amplitude is also fixed. Now what you do is, instead of this capacitance, what you do is you connect a condenser microphone. So here in the place of fixed capacitance, what you do is you connect condenser microphone. So you all know that a condenser microphone will have a fixed plate and a movable plate. That is, you have a fixed plate and this is movable plate. So the higher end positive plate is connected here and the negative plate is connected here. So what will happen when you try to speak the sound waves? This is fixed plate. This is another plate will start moving based on the intensity and the frequency of the audio signal. So therefore what happens is the capacitance is changed. So that's the idea. So what happens is, I will draw the capacitance as it is. So what you are connecting here is, you are connecting a condenser microphone. Condenser microphone means it's a capacitive microphone. One plate is fixed, another plate is movable. So when you speak out, when the sound waves strikes the movable plate, what happens is the distance between the plates is altered. Area will be fixed. You all know that C is equal to epsilon A by D. So when D changes, if D varies, C is also varying. Okay. When C varies means frequency gets varied. So here the output waveform frequency gets changed and the amplitude remains constant. That's how we are able to produce frequency modulated waveform using Hartley oscillator. Same concept you can apply for Colpitt's oscillator also. So the difference is you will be having only one coil here. Okay, in the case of Colpitt's oscillator, you will be having only one coil and you will be having two capacitance. Okay. So So here it is grounded, C1, C2. You can put the condenser microphone either at C1 or C2 in the place of C1 and C2. Therefore, when the sound waves strikes the variable plate of the condenser microphone, capacitance gets changed. The distance between the plates gets changed. Therefore, capacitance also changes. Therefore, indirectly it changes the capacitance value. So in this case, C1, C2, C is equal to C1, C2 by C1 plus C2. Okay, because it's in series. Therefore, what happens is, if I am choosing C2 as the condenser microphone, C2 will change. When C2 gets changed, overall C value gets affected. Therefore, the frequency of oscillations at the output is altered. Thereby, we are producing frequency modulated waveform. So, the concept here is, in the place of capacitance, we are going to use what? Variable capacitance. So, variable capacitance in the sense, one plate is fixed, another plate will move. Such kind of microphones are called condenser microphones generally, or you can call it as capacitive microphones. So that's all about this frequency modulated signal generation using Hartley or Colpitts oscillator. Thanks for watching this video. Nandri.